Hi everyone. So, just to first of all start off, so I haven't delivered this course. I'm about to deliver this course start delivering this course in 2 weeks' time. It's my first time doing the Quantum World module, which is a second year module, a core module. So off the order of 150, 160 students, something like that. I'm absolutely terrified at the moment. I need to put that across. And I will echo exactly what Catherine said. This is the way I'm thinking about things. This is the way I'm going to try to do things. It could very well all fall over in the first week, but these are just some of my ideas. This is not something that everybody should try. It's what works for the individual, and it's what works for the individual students and the classes of students. There's more. I've got the blog link down right at the bottom there. There's a lot more in terms of my thoughts on this and how this has evolved over the last few months and indeed over the last few years. So I want to stress, I remain very uncertain about it all, but I'll try and put across what I plan to do. Okay, so this is a guy called David Merman. I quite like this photo of him because he looks a bit like Columbo, I think, in this one. But he's associated with this very, very famous dictum when it comes to teaching quantum physics at any level, which is shut up and calculate. It's so mathematically complicated, it is so conceptually difficult. Don't get bogged down in the philosophy of it all. Just do the maths, do the integrals, do the bracket notation, do all of that, and outputs the results at the end. That's not something I'm very comfortable with, and I guess there might be a bit of a divide here between experimental and theoretical physicists, in that of course the maths is important, but for me the links with experiment are key. And also, although there's a lot that we don't understand about quantum mechanics, there is a lot that we do understand about it, and it's a question of getting those concepts across. So the conceptual basis is really key, and this focus on sort of forgetting about the concepts, forgetting about the grander philosophy, and just focusing on the math. It's a great book. I recommend it to everybody. Anybody who's got an interest in any type of physics, physical chemistry, teaching quantum, or basically where theory is going at the moment. You can see that how beauty leads physics astray, lost in math. It's about how there's a little bit too much emphasis on putting the conceptual framework to one side and just doing the math. And there are two other great books there that I'll certainly be recommending to students. One by Adam Becker and one by Philip Ball. As you can see, What is Real, Beyond Weird. These have just been published. All three books have just been published in the last few years. So we are really at a point where if we're going to push the field forward, or indeed if we're going to teach this quantum in a much better way than we have done historically, we've got to think about getting beyond this shut up and calculate idea. And the shut up and calculate idea clearly hasn't worked, because if you look through the literature, there are hundreds, if not thousands, of papers about misconceptions regarding quantum mechanics. This first one is from, as you can see, all the way back in '95. It's from American Journal of Physics, which is a brilliant journal, I've got to say. If you've got any interest in education in terms of physics and physical chemistry, it's an exceptionally good journal. But that's just one. There's another one more recent: Framing Difficulties in Quantum Mechanics, Overcoming Misconceptions, Student Misconceptions, Improving Student Understanding, Student Difficulties. Time and time and time again, quantum is difficult. We know it's difficult, but I think we do them a big disservice by saying shut up and calculate. We also do them a big disservice, and I am as guilty of this as anybody, by saying, well, it's really weird, and that if we all quote Feynman saying that, well, if you think you understand quantum physics, you don't really. That's a very bad message to send out right at the start, because it puts them off right at the start. And those conceptual doubts can be really, really broad in terms of, well, what's it all about? What is the wave function? What is the nature of reality? Is it ontology, epistemology? All of those types of very broad, big, general questions. But even at a much lower conceptual level, in terms of the understanding that they should get from a first-year course, and I taught a first-year course as part of something called Frontiers in Physics. Here's a very good example of where we, as lecturers who have been teaching this for 10, 20, 30, whatever, N years, we have a certain way of putting the information across, and we forget, and I certainly forget, just how difficult it is for students coming to this topic, particularly quantum, for the first time. Now, I'm not going to get bogged down in technical detail, I promise you, but I think this is an important example to bring across, and it's something that I think with the shift to online teaching and online learning, we can really do a better job of countering this type of misconception. So this on the left, for those of you who've done any type of quantum, or if you've done been involved in teaching or indeed just applying it, but even if you've not, you'll see that what we've got there are different standing waves, n equal to 1, n equal to 2, n equal to 3, n equal to 4, n equal to 5, etc. And even in this is taken from a physics textbook, you can see the bit that I've highlighted. Caution, big bold caution. The 5 graphs have been displayed vertically for clarity. Each of the horizontal dashed lines represents psi is equal to 0. And yet, and I make that point, and I know many other lecturers in first year have made that point as well, and yet, so we get graphs like this. This is just a random one that I've taken off the web, and you can see what's happened here. You've got the wave functions, and then on the axis you've got energy. That is just begging for students to misunderstand it. And this is absolutely key, because right from the off we're confusing them between the difference between the wave function, the function, and the energy. And that's a very bad place to be. So this is from actually Frontiers in Physics, a course, a first year module. I taught the nano component of that for well over 10 years. This is from just one example from 2014, 2015. We used to use the clickers, so for real-time interaction in the lectures. And so here's an example of that type of question, and just probing their understanding and probing the conceptual difficulties during the lecture. And that's key. So it says the wave functions with n equal to 1, 2, and 3 states of a particle trapped in infinite potential well as shown. For an electron in the n equal to 2 state, so bang in the middle of this well, let me just, I don't know where my video is compared to where, I don't know if you can see this, but bang in the middle of the well, it's the wave function as a node. Now here's the question to ask students. The problem here is we've combined 2 things on this graph. We've combined the wave functions and we've combined the energies, and we've offset the wave functions. There's a lot conceptually going on there that we take for granted and that the students just do. A sizable proportion of the students don't get. So there's the various answers, and what I wanted to say from them, are they going to say, well, is it 0, or they're going to get confused and say it's E2? A third of the class in this particular case got confused and said it was E2. That number has been as large as 45%, despite me saying time and time again, don't get confused by this, don't get confused by this, don't get confused by this. And you ask that question and they get confused. Now this is about the most fundamental basic misconception you can have before we get into anything more complicated. So I am firmly of the opinion that moving online is going to help us teach this subject, or pretty well teach any subject, in a much clearer, much less conceptually confusing way. I will in a little while come back to, in the next few minutes or so, come back to what Catherine said. I echo an awful lot of Catherine's points, but that scroll of death thing with Moodle, I agree entirely. I hate Moodle. It's a cluttered mess. Every time I have to go into Moodle, my heart sinks. So you can only imagine what students think about it. And so I will try, I'll mention later on exactly what I'm going to do to try to, we have to use Moodle, but there are ways of using it that bypass that clutter. So I'm planning to use different blog posts. So this is a personal blog. This is just a demo. And it's very straightforward in WordPress to just embed demos, to embed JavaScript, either your own or that you've taken from elsewhere, obviously with credit. And here we don't have those, we have the ability to animate this thing, we have the ability to move things around, we have also the ability to combine it directly, just having a video tutorial directly after it, or sound samples, whatever you like. So let me just move on from that. And as I said, there are many different ways of visualizing it. You can write your own code, you can import codes, you can modify those codes. Putting those codes and putting the JavaScript into Moodle sort of works a little bit. I've played around with it, but it's so messy. So my idea will be to do something which is very similar to what Catherine did, is you sort of just have basic links, and just in what I want to have is for each lecture, as it were, or the content for each lecture, just have one link for that going out to a WordPress blog, whereby you can embed everything cleanly, neatly, and have everything running together. I am not a fan. I love lecturing. Done it for many years and get a great deal out of it. Feedback's fine from the students. I am not a fan of lecturing. I think we've been doing something for hundreds of years and it needs to change. And with COVID and this pandemic, actually, I think it's a good thing that we're being forced to change away from this. That's my personal view. Others might beg to differ. We can talk about that in the question and answer session afterwards. Did this video with a guy called Brady Haran. Many of you will know Brady. He's behind a range of YouTube channels at the university, collaborates with him on one of these is 60 Symbols. We did something called Death of the Lecturer a little while ago, and there's also this blog post about it. That Virginia Woolf quote is quite sharp, I would say, and perceptive. The problem here is when you go down and look at the various comments under that video, and there are many, there's well over 1,000 now, and YouTube comments don't have the best reputation for very good reason, but in this case they're quite intelligent, quite erudite comments. And one thing that does come up time and time again is, I like lectures, therefore they should continue. That is not a particularly good argument. There's also this, and so I'm debating with my colleague who used to be head of school, Mike Merrifield. Many of you will know Mike, and that's what this video is about, the death of the lecture. Mike says the lectures continue to be valuable. I have some suggestions otherwise. I think Prof. Merrifield cut closest to the heart of the issue. It's more about the quality of the instructors than anything else. I disagree entirely. So just to let you know where I'm coming from, for any type of deep learning, the intellectual heavy lifting has to be done by the student. And it's all too easy for somebody to explain something enthusiastically and clearly, and for you to come up, oh, I get it now, only to realize, well, no, you don't get it. Is the Times Higher from a few years back, great lecture, what was it about? When they actually tested this and took a very enthusiastic, charismatic lecture against somebody who went in and basically looked at their feet and spoke in a monotone, there was very little difference in terms of the overall student performance. So it's something, this blog post down in the right corner here is from quite a number of years old. It's something I've thought about for quite some time. There's also a key role of confusion here, which might seem absolute heresy for a lecturer to say, but the key, I don't know about you, but many times when I finally get a breakthrough in understanding something, it's after I've spent a period of weeks or months going, I just don't get this. And it's that forcing yourself through that confusion, which is absolutely key to any type of deep learning. Okay, so I said there are many, many, many conceptual surveys out there, lots and lots of very good questionnaires put together to test students' understanding of quantum mechanics, but those happen either before or after a course, or both before and after. For me, why do we do that? Instead of having a conceptual survey at the end of the module, why not make it an integral part of the teaching? Why not have discussion? Why not probe these concepts as we're going along? It makes no sense to me to dump a huge lump of huge block of very complex, both mathematically and conceptually in terms of the physics material on students, and then probe their understanding right at the end. We should be doing that as we go along. So this is something I experimented with quite a number of years ago, 2013, 2014, did YouTube videos, and then you have the YouTube comments section. There's that wonderful XKCD cartoon on the right there, which explains just why YouTube comment sections are perhaps not always the most intelligent nor the most informed, but it worked reasonably well. And you can see there are questions popping up under the video, and that leads to more discussion either in the video comments or via email or via various other types of chat. There's a wide range of different conceptual questions we can ask. What I plan to do, and I'll outline this in a couple of slides' time, is to have chunked material just like Catherine described, and then use the actual synchronous sessions to have questions like this to poll students' responses and then discuss those. And I could go on and on and on about the difficulties and the issues there are with sort of standard methods of teaching quantum. Those are very good point there. However, it is easy to memorize the method or solution for such specific problems and difficult to apply this method to an entirely new problem. That's particularly true for quantum. Moreover, and I'll be very brief on this, I know I'm going over my time, even compared to 30 years ago, stuff that were Gedanken, thought experiments, even 30 years ago, we can now do in the lab. Fortunately for me, my research area is something called scanning tunneling microscopy. We manipulate individual atoms, we move individual molecules around. This is what an STM can do. It can build up those corrals, it can build up those boxes that we talk about, and that helps students having a visual representation of what's going on here. To get beyond the shut up and calculate thing is really, really important. And these are not new papers. The one on the left here is 2005. The one on the right is from a PhD thesis in 2010. Beautiful. And moreover, for those of you who do quantum mechanics, you can even map out the dispersion on an experimental level to compare with what the theory predicts. Okay, penultimate slide. This is what I plan. So the delivery of the primary content will be, as Catherine said, via asynchronous videos. And you can get a lot with an iPhone. So Brady and I have done a couple of videos now whereby it's just shot on an iPhone. The video quality is pretty good, is more than good enough. What's really important, however, and I hope this microphone over here is working as I say this, is good audio quality. It's interesting, we can tolerate crappy video, but we're much less willing to tolerate crappy audio. I use something called Camtasia, which is the university has a license for this as a video editing package. I'll be honest, up until the most recent version, Camtasia was bloody awful and it was really difficult to use. It's improved a lot with the most recent version. I plan to do exactly what Catherine did in terms of with the mathematics. I will use a document camera, or I will have a webcam just looking down, watching me as I write. I think there's something very psychological and something very important to see the lecturer, particularly in quantum, work through the mathematics in real time. And I'll have a dedicated YouTube channel, and I will upload the videos there. In terms of what we do for the synchronous sessions, in terms of the one-to-one or the group interaction, that's, as I said, is the idea is have conceptual questions, real-time polling, Microsoft Forms. I've experimented a little bit with this, allows you to do that, chat and in-person discussions. And then what I really hope I can set up, I haven't tried this yet, I know it's possible in Zoom and it works really well, I hope it's possible with Teams, is in terms of setting up breakout rooms. However, I'll stress this again, I absolutely hate Moodle. It's a cluttered, awful mess. So what I plan to do is do exactly what Catherine suggested, try and minimize the number of links in Moodle. In fact, ideally what I want to have is have lectures and then just a series of links for each one of the lectures, or each one of the themes even. And then link those to WordPress. And WordPress just seamlessly integrates slides. You can use SlideShare, notes, JavaScript, YouTube video, audio, polls, social media. So with one-click links from Moodle. Okay, but I will say this in terms of the take-home message. I'm very uncertain about it all, and I'm very worried about it all. Thank you.